Hey folks, okay, next Ethernaut challenge, level 6 delegation. Let's see what we got. Okay, so I've already got my contract instantiated because that's really boring for you to watch. Here's source code. Okay, so actually we should read the hints at the top. The goal of this level is for you to claim ownership of the instance you are given. Okay, so it'll be an owner variable that we want to own. Or well, set is our addresses to be more precise. Okay, look into Solidity's documentation on the delegate call, low-level function, how it works, how it can be used to delegate operations to on-chain libraries, and what implications it has on execution scope, fallback methods, and method IDs. Okay, great. So let's just make sure this is good address. Okay. Oh, we need music. Awkward silences need to be filled with something. Okay, so sources, what do we got? How does this work? So 2 contracts. We have delegation and delegate. So it looks like delegation calls delegate. Fine. It has a interestingly named function called own. Okay, so to own this contract is really simple, right? We just, when it's created, whoever creates it can set the owner at creation, but then anyone can call this pwn function and set the owner of this contract to whoever's sending it. So that's really simple. This contract that we have, contract variable we have here, let's see what we got. It's got the fallback owner and non-payable. So this contract here is actually this delegation contract. It's not this top one. Because if it was, we would see this pwn function inside the ABI, and we don't. So, no, that's my assumption, but that's what I would expect to see. So in the delegation one here, okay, the challenge here is then how do we own the delegation smart contract, right? So when it's created, it's set to the whoever creates it as the owner. And then we see nowhere in here actually being able to set the owner again. But you can see the delegate call. Okay, yeah. The delegate call is kind of what we want to try to exploit. What we want to do is get this here to actually execute this function and then set the owner of this contract in that execution, right? So if we send this message, we invoke this fallback function, it then invokes this, which calls the pwn function, and then we need the context when that pwn function is executing to be inside this contract. The way we do that is with delegate call, and not the way we do it, the way they've kind of coded this obvious vulnerability into this contract. So let's take a look at delegate call, see what we can find on it. Delegate call. Jump to the Solidity documentation first. Just jump back to the documentation in question, or sorry, the version in question, which is 4.18. Okay, so let's see what they say about delegate call in here. Delegate call. List of known bugs. Delegate call. Delegate call. Okay. So delegate call, issue low level, delegate call, return false on failure. Yeah, so if the function that's called reverts, I think it returns false. I don't think it actually throws a revert in the contract that we've called initially. So not much help there. Where's the other delegate call? Introduction to smart contracts. Delegate call here. Okay. There exists a special variant of a message call named delegate call, which is identical to a message call, apart from the fact that the code at the target address is executed in the context of the calling contract. That makes sense? Hopefully it does. This means that a contract can dynamically load code from a different address at runtime. Okay, so where are we? So delegation, let me show how I think this is going to work. Okay, let's put this in a Solidity file as well, so we get some syntax highlighting. Okay, so if we kind of walk through how we want to exploit this, we want to call this fallback function. When this fallback function gets invoked, what's going to happen is it's going to call delegate.delegate call and then send the data in the message of our transaction, right? So delegate is actually this delegate contract. So what'll happen is it will push onto that delegate contract our message data. So what we can do with message data is actually push the name of the function we want to call. So what it'll actually be is pwn. So this will actually be pwn. And so what this is really going to do is going to do delegate.pwn more precisely. Okay, and since it was the delegate method, what's actually going to happen is this contract here is going to get executed essentially in here, inside the context of this delegation contract. Okay, and that's what this was kind of getting at over here. So then this is going to execute inside the context of this contract. So essentially it's going to do owner equals message.sender. Okay, and then that's going to execute, it's going to return true, and then this function will finish, hopefully. And then that means that we've overridden the owner with the message.sender, and we now own the contract. And then I don't know if it wants us to own this delegate one as well, but we can call this pwn directly on the delegate one. Okay, let's try it out. Good in theory. So in order to call this default function, when you send a transaction to a contract and you either the name of the function doesn't exist, it will go to the fallback function. So we can basically try to invoke delegation dot blah 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 blah, and it would go to the default function. But then the data in our transaction, we need to have it call the pwn function up here. It needs to have the data to call the pwn function. If that makes sense. Hopefully it does. Okay, let's give this a shot. So in here, what I want to do is something like this: send transaction, and I want to say data, and inside data, I want to basically say pwn. I can't just say pwn, but something like that, right? And hopefully that's all I need to do. Be pretty simple if that's it. So let's do that in our kind of more consistent environment we've made. So this is a contract we want to exploit. And I don't even need to instantiate a contract object, because I can just send a transaction directly to this contract. I don't care about any of the ABI stuff. So let's, okay, so clear. No, that doesn't exist. Okay, so if I do web3.eth.send transaction, okay, that's what I want. Oh yeah, sorry, I need to convert pwn to a, well, I need to SHA-3 this is what I need to do, because it's not actually going to, I can't actually pass this as a data. I need to pass the SHA-3 of that method in the first 8 bytes of it. So the way I can do that is in utils. If I put utils at the top level, no. So web3.utils.SHA-3, okay, that's cool. Probably give it pwn. Okay, and then I'm just going to take the substring of that, and I'm going to go 0 to 10 because I want the 0x at the beginning, which isn't really part of that. It's just the hash value. So this is what I want now for my data. So I'll go web3.eth.send transaction. Okay, I'm going to go 2. Actually, let's do that. So 2 equals, what is it? This address. 1 second. Sorry. Okay. So 2 is the contact I'm calling. From is the contact I'm calling from. So eth.accounts wallet at 0.address. Okay, so from should be that one. What are the other bits I need? Data. And data is that. Okay, so now let's do web3.eth.send transaction to from data. Gas is missing. Perfect. Okay, gas. So what do I want for gas? I'm gonna go var gas is equal to 100,000, and might need gas price as well. So var, actually I may already have gas price defined. Yeah, I do. Okay, so send transaction, gas and gas price. Gotta have those spaces, very important. Crap. So I didn't I didn't do anything with this promise to print out the result if it worked. So that was stupid. Let's just run it again. Total.log. Over here, why don't I, well, this is contract, I'm just randomly sending transactions out all over the place. Reject, okay. Owner, wait, okay. So I've already owned it. Okay, so that worked. So before, it was whoever created the account, and then this transaction here, which is now returned, did exactly what we had described. So that was easy. Well, sorry. Let's see if this actually works. So submit. Confirm. It might actually want me to own the other contract as well, which is just calling this pwn function. Because I don't have a contract object, I would just do it manually with another transaction. Okay, there. Yay, completed the level. We need to have some sort of video of something exciting happening. I got nothing. All right, thanks.